Hello. Doing pretty well. How are you? California. Uh, yeah, I'm based in California. You? Oh, nice. Uh, Pretty much, doing some, like, fire simulation. Uh, Kind of show you what I've been working on. Let me just pull some of this stuff up. But it's basically like what I'm doing is like a CGI flamethrower type effect. I'm just kind of R&Ding the look of the fire. Should I turn some of the music down? Yeah. There you go. Yeah, so this is some fire testing that I'm doing. The scale's kind of off. Like this feels like the details need to be like a lot smaller compared to like the size of the human that I have like for scale reference. So, uh, kind of working on trying to get smaller scale details, especially for like a fire that's supposed to be that big. Oh, thank you. So, yeah, this is pretty much uh, what I'm doing, but I'm trying to like get this uh I do play games, but I don't typically like stream games that I play. I I play a lot of Destiny, and getting a little more into it now with like the new expansions coming out. But uh, I mean, this is like what I do for work for a living, so I'm just kind of like streaming now. Um, because I don't think there's a lot of people that do like full CG uh type of stuff. You see in the movies, but like I don't think there's a lot of people that do it live. So I'm just kind of giving it a try. But yeah, I do play games. I play mainly Destiny, some like Sea of Thieves. Yeah, I learned hi Gary. I learned Houdini in school. Yeah, so I went to Noman in Hollywood for like their 2-year track. Oh, thank you. Uh yeah, so I was like in the 2-year track at Noman, but then I've been working in this industry for about 8 years. So, uh now I'm just kind of like, especially with the whole like strikes and stuff, I've been kind of like working um, and wanting to get back into more personal projects and doing something um, more on the side. Yeah, sure, go ahead, ask away. Yeah, so like this is like a really low res fire, but um as I was like showing Brenda, was like I'm getting some nice flame details here, but the size of the fire is like still too big, so kind of working on getting the scale back. So if we look at the scale here now, um, like it's a little smaller, so I'm just trying to get more accurate detail representation. So then when I apply this back to like the big flamethrower that I was working on, the scales should line up. Like, so if I go to here, that's an older one. So I have another scene file. That's older one. So this is like some flamethrower emission stuff I was working on. So I have like an emitter that's kind of working, but the flames aren't kind of working here. They feel very slow. So um, now I'm kind of going back and like, yeah, just working on a simpler scene with like trying to get smaller details and then apply it back to this one to get like the larger details. Yeah, Brenda, if you want to send me your work, I could take a look at it. Let me see, find the best way to do that because I don't think I have it set so people could share links in chat. There was like one night I was streaming and there was like 5 different bots coming in and entering the same messages. I was trying to find a better way to like get rid of it. Uh, yeah, I have Discord. Uh, yeah. I think if you okay, let me add you. Yeah, yeah. So the goal, Gary, is like to do everything kind of live here, and then take all the stuff that I've made, once it's like polished and final render, and apply it like as a workshop, like a learning workshop on YouTube. Um, and then we'll do another project, like Like I think I want to do maybe like a water project next. Um, and fire is like the least area of like expertise that I have in Houdini. Like I've done, yep. Oh, it's art by Brenda. Okay, I sent it. Yeah, so hopefully we can kind of wrap the fire up soon. Yeah, it's just kind of fixing some of the details. Cool. Cool. How long have you been doing like designing and stuff, Brenda? Try turning up the resolution again. Yeah, your portfolio is pretty cool. 5 to 6 years? Nice. Is a lot of this stuff static, or is it like actual like for the stream overlays, or is it like a do you have like animations on those? They're pretty cool though. Yeah, I think the fire's it's getting around. I have like a car model I made, or I didn't make it, but I downloaded to test. But uh, yeah, I do renders also. So um, yeah, since it's kind of still like in the R&D phase, I don't have any current renders. But I mean, the goal will be to make like a final render product of it. Uh, which I mean, like, yeah, like this probably needs a lot of work shading wise too. So um, the first battle will be like getting the details right, and then going in and getting the actual like render version of it. But I think like the scale's getting a little better. I mean, it's missing some details now, sadly, but uh, okay. So like, yeah, so Pyro has like this shredding, which is supposed to like add um a lot more detail to like fire, but it's not as easily to dial in. Because they do basically do like this like squash and stretch, like a bouncing ball method. Uh, which I did some wedges. So like another part of the setup stuff that I did was making a bunch of like wedges in Houdini of it. So we go here into the
Art with Brenda 5 just followed.
Thank you, Brenda. Thank you for the follow. Uh, yeah, so I actually have videos for these ones. So if we go video, so I've tested like different settings on the fire, like on those parameters. Um, so like this one, uh, let's see a good one to mess. So there's like the scale here, which is like the amount. Yeah, so shredding is like used specifically like for fire type stuff. So like you could see the shredding here is almost like non-existent on the left, on this top left one. And like as you add more and more, it's basically taking um information from like the velocity and the gradient and like adding more and more over time. So then like this bottom right one, the scale here is set to 0.75. So I mean all these other like controls mess with it as well. So like like the squash and stretch. So like if I could pull up like what the squash comparison here. So you can see like, oh, I hate VLC sometimes. So like if you can see the squash here. So like here it's set to a value of 1, and then we have 4 and 7 and 10, and that's like I guess like the noise scale, like the frequency of the noise. Um, So yeah, I'm just trying to like find the perfect values in here. And then I have some custom stuff on the side here, that I think is adding to like some of the details here by like putting some more velocity, or like curl velocity, um, in the simulation. And I was trying to take the curl velocity generated from that and plugging it in to the shredding, because the shredding takes a velocity field. So I was like, well, maybe if I take this detailed velocity, which I named like curl temperature, but that's actually a float field, so maybe that wouldn't work. But I could try something like this, maybe. So oh, like on the gas field wrangle here, or yeah, I'm not interested, Brenda. Sorry. Yeah, so like this one here. Yeah, so what this one is doing, um, so basically, this whole process is doing here is adding a something for the advection. So here I'm creating like a temporary field called normalized temperature, and then another temporary field called like curl temperature, and another one called like curvature temperature, and then to create the normalized temperature, I'm just calculating the maximum temperature. So like it compares like the max value in each voxel. So basically I'm fitting a ramp between the temperature field. So if we go to this wrangle here, um, I'm taking the original temperature and fitting it between this flame min and max, which right now is a value of 0.5 to 1.5. So basically taking the temperature between these two values and normalizing it from 0 to 1. And then once it's normalized, you could fit it in a ramp. So like the best way to like visualize something like that is how I'm going to the fire here. So on this one on the right, I am taking basically uh, all these points that are they're going to be sampling in the volume, by just visualize. Well, here I'm just using the visualize tree to visualize all the active voxels, and then I'm sampling the volume for the temperature. So if I did like a color here and just did like a ramp from here and did it on temperature, you can see that there's like values in here. And maybe if I uh, did something like alpha, so if I say like our alpha is equal to like the color red, like you can kind of see like these are all the values that the temperatures is kind of reading. And like I don't want to like always have to calculate this, because if we look at the data, like that temperature is right now like a value of like a really low number, which is basically 0 to 2.06. So you can see like the full range here, but like since we want to fit this into a ramp, we need to normalize it somehow. And you can do that with like the attribute promote. So we're calculating the min and the maximum temperature and promoting that to a detail attribute. So now we know what the min and max are by like all those being calculated. And then what I'm doing here to visualize my temperature is with this volume slice node. So it's like, yeah, so the point cloud's coming from the volume. So there's this node called the VDB visualize tree here. So if I like plug this in and we view it, turn off the preview on everything. So this is basically like a representation of the voxels on the volume. And this is just all the active tiles. So you could do like solid boxes. Or sorry, so like here's like essentially all the boxes. So this is like sometimes like in movies like that they do like the Lego movie where there's like fire and smoke and stuff and they look like little Legos. Like sometimes they'll do something like this where they'll visualize the boxes of it and then make the look of like the effect. But here what I'm actually doing is visualizing the active voxels. And I mean I could do like boxes also. But each basically box represents the like I guess the 3D pixel of the volume, and each one of these has that data inside it. So if I do points, then these are all the points representing that volume. Yeah. But there's another node, like since I'm using VDBs, it's a little easier to get this information from VDB data. But there's also like the points. There's a points from volume node. So this kind of does like the same thing, but you kind of have to dial in the resolution yourself. So you can kind of see there's some points already getting added in here. Oh, I see. Yeah, if you have any questions, let me know. Like I've yeah, I could, if you have any like questions, Houdini stuff, I could help you out. But yeah, like you can kind of see the volume here. That's from the points from volume. So it's kind of doing the same thing. And it's probably like a little less data wise compared to the visualize tree, because the visualize tree is calculating it from every single voxel, where this is kind of like filling it in and seeing where the voxel or the volume data is. But yeah, once the min and max, I'm basically cutting into the volume and finding and putting in that range with this detail expression. So here it's using a spare input. So the spare input is a cool way to where if you want to reference another node in Houdini and get data from it. So this is pointing to like my render fire sample. So if I just click here, it shows that node inside here that I'm getting the information from. And then once I'm using that, I'm using the detail expression to get that temperature minimum and temperature maximum. And now we're visually seeing this min and max. The best way I recommend like learning Vex would be if you take like a, let me find just a simple like example. So like I recommend trying to do something in VOPs, and then once you like the way something looks in VOPs, then implement it in Vex. And the best way I could show that is like if I did like a grid. Maybe not for noises, because noises might be a little bit easier to do in VOPs than Vex. But like if I took like a grid here and I, let's say, took the sphere and did a PDB from polygons. So let's say I wanted to color, this grid if it's inside the sphere. So if I make it blue and then we did like an attribute VOP. So if I go inside here, right, like, so we could do something like a volume sample. So like there's a volume sample. So a lot of these things in VOPs have almost a similar equivalent in Vex that you'd kind of have to code. So like volume sample, for example, like there's a volume sample expression. And this, we need to point it to an input here. So there's 4 inputs. So we plugged it into our second input. So if we plug this into the second input and we need to give it a position, so we give it the position and we feed that to color. If we come out here, we could see, we basically created a mask where that volume exists. And then, if we want to just make it red here but keep it blue everywhere else, what we could do is create like a constant. So the constant node, we can make this a vector, and we can make this like red, for example. So if this was red, then what we could do is multiply our red color by the volume. And if we plug this in, now we see we're adding red around that radius. And then if we want to apply it to our original color, we could plug in our original color. And then if we did an add node, but then we can add our red color to that grid. So now we have red and blue coming through. But the point I wanted to get at was like we did all of this, with these nodes here. And if you want to see how that's being done in the VOP network and get like a little bit of a visual representation for Vex, is you can right click the attribute VOP, and there's this Vex VOP options here. And if you click view Vex code, this actually basically is a visual like code representation of what's happening in the VOP network that you did. So a lot of this stuff is going to be very consistent in here. Like a lot of this stuff is like just using the geometry VOP, like everything the geometry VOP is doing, which is just initializing attributes and then exporting. But if you go all the way down here, you could see, there's that constant that we made here, that red constant. There's the source file. There's the volume sample function. So you can see it's getting the input, the volume, and then that position, exactly like how we did it here. And we specified the volume to 0. So what if we actually were to change this to like primitive name, and we did density here, and if I refresh this code and we go down, now we can see like this is referencing density. So like if you want to recreate this in a VOP, like you can kind of see like all the stuff we did here, and now we can like go to a wrangle and create the same thing. So if we go to like a wrangle, we plug in the same inputs. I can, if I wanted to, copy this expression. So you also need to initialize it in Vex. So this is a float, so we need to say this is a float value, and then our volume value, which our source file isn't going to be used this time, so we actually need to specify the input. And another way, if you want to pull up documentation in Wrangles, is if you click on what you want to pull up on documentation for the expression, you could hit F1 and it's something, there it is. So now it's actually pulling up the documentation for the volume sample function. So it's like a pretty quick way of pulling up documentation. And you could just see here, it requires a geometry input, like the prim num or the volume name, and then the position. So the input is our second input, so that's 1, and then we could leave density, and then instead of p like that, we just need to say v at p to get the current position here. And then if we wanted to make that the grid with the sample of the color, we could just say v at color, is equal to the volume value here. And you know, we got the same thing again. Yeah, the documentation could be a little like weird sometimes, but this is like the way I learned it. It's just because it can get, you know, wrangling and like scripting can be a little complex, especially like getting new to it. And I'm not like a guru when it comes to scripting, but like I know enough of it now to kind of do, you know, to kind of get at the gist of everything. So like now that we have this, you know, if we want to add that color to the existing color, we could just say like instead of equals, it's plus equals. So now it's adding that white color. But if we want to make, you know, our custom color, what we could do is we could do that vector. So we can make a vector with that constant, and then we could say color is equal to make some brackets, and then we could say 1 0 0, and then if we say our color is, you know, that volume value, but it's multiplied here, then we're adding that color channel. But if you want to do cool stuff like that ramp stuff I showed you, you know, we could take this a step further, and instead of doing any of that, we could use a ch ramp function. So we could plug that volume into a ramp, and then we can name this attribute like remap. Remapped volume. And if you hit the gearbox here and we do the edit parameter interface, instead of that being a float, we can make that a color. And if we plug this in and let's make this like infrared, now you could see, you know, based off of that volume, we are now coloring everything inside that volume, you know, with this ramp. So if we wanted to do this in the attribute bob, you know, we could do the same thing. We could, instead of multiplying everything by that red channel and adding it, we can still add it, but then we could, you know, plug in a color, ramp. And if we make that, that's actually default by RGB. So if you make that infrared, you know, we're getting the same exact result from both. And then, you know, if we view vex options, view vex code, like it's structured a little different. So you can see they're using a spline for their color. So it's going to be a little different sometimes. And they're like, you know, converting it to a specific color space. So like it's a little different. Like sometimes when you make the code in Vex, but like you can kind of get the workaround from there. And then another good place of documentation is like the CG Wiki. I don't know if you're familiar with the CG Wiki. But if you go to like here, you can see like Vex 1, and you know there's some like good documentation here too, for like just setting up attributes, like how to set it up properly. And then like they get a little more advanced in here, like some actual examples, like you know, making like a radial ring. Oh, okay, I see. But that's good. Like that, you know, Google's like, especially learning this type of stuff. I would say Google's your best friend because there's more than likely someone that's had something similar that you're trying to solve, and you know, you might find something that will help you, you know, solve that problem. So there's like a lot of cool options on here, but yeah. Um, so that's all we're kind of doing with the ramp and like normalizing attributes in that dot network. Um, but like this volume here is pretty much like default. So this is going to be like a, you know, like a really nice fall off from 0 to 1 here. But like when you're dealing stuff with like temperature and stuff in Houdini with like fire simulations, you know, that's not like a exact 0 to 1 value. So that's why I kind of have this slice here. And then I have this line writer HDA um, that, you know, is showing us live. It's showing us live what those temperature values are. So, you know, these red values we're seeing here are our maximum values, and then these like cool like purple areas, that those are our like very minimum values that we're getting. Um, yeah, no problem. So you can see if any of this is going to make a big difference. So you can see some stuff, weird stuff's happening, like this. Let me pin this window. But it looks like the shredding's, you know, causing a lot of expansion in these areas, which isn't really applying to the look of the flames too much, I think. But you know, based off of like all these comparison videos I made, we can kind of like with all these wedges kind of see what, you know, settings we want to try using. So like we could try the squash at a value of 1, which it already is, and then we could look at the stretch values. So you can see how like the stretch values here are changing a lot. I mean, those are really high values. So maybe we try 0.65. And then our temperature threshold, which ones? That's the temp threshold. So click here. Which this one might be a little hard to see. I think I'm liking this one a lot more. So that's like a 0.633. So do that. And then there's the threshold wish, which is that fade. So we go to the fade here. I don't know, they all look very similar. So maybe you don't mess with the fade too much. This one kind of shoots out occasionally. That looks a little weird. Like this one, I guess the bottom ones are behaving a little bit better. So yeah, that's the threshold width. So if we go to the threshold width, we can just do like 0.7. Yeah, so I did this a while ago. Let me pull it up. I did this with the white water solver in Houdini. Which if you've looked at that solver, like you would know that that thing's like pretty crazy. So I have them all on my Google Drive now. I don't have them on my computer anymore. But I took every parameter of the white water solver in Houdini and did like a wedging test. And this was probably like a couple of months running on my machine, or not even a couple months. This was maybe like a month of testing and then going back and running all these settings with PDG. So like if I go to, like, you know, I want to see what clumping settings. I basically ran a wedge of every single clumping setting. So if I go to like the this tensile strength here, you know, just by this image, there's like a little bit of differences. So, you know, just testing like different settings in there, like another like desired neighbors. So some of these, like, they didn't really change too much because a lot of them are like dependent on, you know, different things. But I was able to quickly see that like repellent settings, for example, so like repellent settings, like I guess that one hasn't changed either, but let me find a good one. Maybe the velocity multiplier. No, lifespan will definitely look different. So if you go to the lifespan here, like some areas, you know, are dying quicker than others. Just kind of testing these settings and like having these settings up. Which is very poor quality on Google Drive, but that's a little better now. So, you know. So like, and I did this at 2, so I have, this is like the close-up settings. And then I did another test like further away with the same wedges. So like if we go here, yeah, it is satisfying to watch. So if we go to the lifespan here, let me look at this one. I basically made some sort of like, you know, force blasting out of the water with the same type of settings. So you can kind of see there's like more like foam residuals on the water on like the bottom right one than like the, you know, the top left corner. What's another good one? I think the clumping has some really interesting ones. When I keep looking at the clumping, yeah, so like the repellent settings probably changes a lot of it too. So yeah, I did like, you know, 2 tests, one further away, one closer, and just kind of wedging these and comparing them. So I'm just kind of testing the same stuff with fire now, but and then like I did keep all the information on it, so if I pull that up, which I'm starting to hate Vimeo. They changed a lot of stuff on Vimeo that I'm not a fan of. I could put that here. So this Vimeo video will have the link to the Google Drive. So like, you know, if you ever wanted to take a look at that. But we do like an incognito. Pull it up. So yeah, it was like, yes, 272 simulations for each one, and then 34 parameters, and then 4 wedges for each one. And that was like 219 terabytes in total. But the way I have it set up in Tops is it once it caches the frame and takes the image, it deletes it. So then like that's how much data it would have been total if I stored it all. But you know, after keeping and deleting after I've, you know, made the images, and then the images were 320 gigs of images, and then, you know, I compressed all of those down to videos. So yeah, it's fun. And I basically took the same exact setup that I did with that, which is kind of this top network here. So here I have like a controller that I can point to the node, and then I just kind of name the parameter here in the controller, and then that gets linked in this wedge test. And here I could just set my range of like the values I want to test, and then that gets divided by the wedge count here. So this is 4 here, and then you know, if I have like a bunch of more here that I have disabled, but if I wanted to, you know, run them all overnight, then I could do that. And then if I hit Shift G, you can see like now that's gonna run 36 simulations, and then all those simulations kind of get fed into this feedback loop. So this geometry output here, you know, this does all the caching and handling, and then once the caching's done, it runs the image generation here, and once the images are done, it deletes the cache from disk, and then when all of those are done, it partitions them back by the parameters. So because you can see here it goes from like 36, before I go here, so it's like 36 tasks total. So this is just to kind of make sure it's still within each task, and then that gets made into the MP4s here, or sorry, and then it makes the comparison video. So there's a video of each one independent, or images each one independently, and then I have a cop network that builds the comparison video, which just, you know, puts them in each corner, and then this makes the videos here. So this node, the MPEG video, takes the image sequence and then spits it out into videos. So then, you know, I could run all of these overnight, and then in the morning test it with all the settings that I liked, and then, you know, try plugging in all those settings. So we can kind of see how much of the fire has changed now, after, you know, dialing some of the settings, which seems like it's kind of swaying a little bit more. Which I probably should get some sort of reference video up too, because, you know, like reference is also like another important thing in Houdini, is like making sure that we're trying to match. So like I have like a Flamethrower reference video. So like this is the video I'm using to compare like the Flamethrower settings, or like not but to get the look for the Flamethrower I want. So ultimately, like, this is the end goal, is to create this effect. But yeah, I'm just like really testing the fire, and I want to make sure I get the fire in a spot that I like, and then start testing it like at that scale. Which I think we're getting a better scale now than before, so it might be worth just like running a flipbook and just kind of see what this looks like. So, like, I'm seeing a lot of details here, like in the slice, but maybe there's just not enough coming through. But as long as the flame starts looking a little better. Yeah, so ideally, you know, with all these comparisons, it would then be to like run a final sim with any of the settings that you like. So like in the UIs of like those videos, like we have all those parameters that we're linking in the text. So let me go back here. So, you know, like if I go to this video here, like, you know, this is controlling the temperature width here. So like in each one you could see like this is the value of 0.1, that's 0.4, 0.7, and 1. So you know, like if I like the way it looks, you know, in this video, then I know like that's a value of 1. So then I could look at the other comparisons, and then, you know, like if, you know, I look at the scale, you know, for how much in total, which I mean it might have to get dialed in again, you know, like because it's not 100% perfect. But like if I wanted like maybe this scale for this fire here, you know, that's a value of 0.283. So then, you know, if I combine the two, I could see what that looks like. And if I'm happy with it, then, you know, run a final cache and then run the other elements. So like, so for the flamethrower, you know, it's me currently like iterating on like the details for the fire. Like, and then ideally to apply that to this, so then we can get a better, like more realistic flame being emitted from the fluids. Because I basically, and here I have a fluid simulation for the fuel, and then I'm using the fluids to emit the flames. And then, you know, if the fluids burn up, or in my case, I'm killing it by age. So if it gets to a certain age, then, you know, the fluid will burn up and then the flames will die off. So yeah, so it will be ultimately to apply that to this, and then hopefully get, you know, something like that that reference video I showed, some sort of comparison, because that would be like the ultimate end result. So getting some nice flames. Might have to test. It's looking a little decent. I think the scale though is getting a little better. Like this feels like a, you know, a smaller flame than the previous one I showed. Let me go here. Yeah, so like it definitely feels, the scale feels better. Like they feel the same. Like this feels like it's a close-up version of what we're seeing here, which I think it's ultimately working a little better. So could try like applying this to a different source now or something. Which like, yeah, so like the next steps, yeah, would be shading. Like if I wanted to like, you know, render this fire, then it would be like, okay, well let's start rendering it and messing with the shader. But ultimately, like, you know, with this, you can see the details and how it's looking, and then the shading is just gonna, you know, up it the next steps, and adding motion blur and that type of stuff. So one thing we could test, so I have one setting that I'm messing with here, and it's the cooling rate. So that's how quickly the flames die off. So ideally, if I reduce this by half, the flames should rise higher, and hopefully the details are still looking the same. Yeah, it would be like Houdini or render engine. Yeah. Yeah, so like it would be then applying like a shader to it, because right now like we're seeing the temperature values like a viewport representation, and then it would be, you know, like taking this data that's of the volume and then applying that with a volume shader, and then apply like actually rendering it. Where I know like in games, like maybe in some games like this would be enough, and then they would run a flipbook, kind of like of the flipbook that I'm doing, but like a more polished version, and then they would make textures or something out of that and then plug it in the game engine. But in our case, yeah, we are gonna like render it, probably use like Solaris for rendering. So doesn't look like too much is changing. So we could plug this stuff back into that I was doing, this ramp, because it looks like that was all turned off. So hopefully with the two combined, we'll get some interesting result. I do. Yeah, it's more like for personal use, but yeah. Let me send you a link. Here you go. Okay, so yeah, it might be worth testing a different emitter now. Hopefully this holds up. here I just kind of brought in a car model. And then I painted some areas I think where I want the fire to start, which that would be a lot easier. Or might not be like the most accurate place, but should be able to go here. If we visualize the temperature. So we could try a bigger scale now. Or even better, maybe I should just do like a grid. Maybe we'll do like a, you know, like a grid with some points. Because it is kind of important to test this at the scale that we need it to be. Now that we have like the smaller scale details in a good spot. Oh.
Their work complete, are headed back to the lab. Testing 1, 2.
Maybe we want the spread to be a little less.
We should have something for us by noon.
Cache this. Mouse fast. Okay. this. Oh, fun. Get that file back. Okay, file's back. So I think with the different source, it's going to be a little bit of dialing it in. I think I could just try like multiplying the source itself. So what? Okay. There you go. And I'll adjust this again. So, okay. There you go. Might make them a little stronger because of the forces. So we could plug this stuff back in. I'll save again so it doesn't crash, or so if it does crash. And then run our comparison. Oh, we should get something, I guess, similar to this one. I need to adjust the grids. So I think I'll just move the fire a bit over. And then for this one, I really want to see how high these flames can get, the details. So I'll turn down the cooling rate and adjust the temperature. So it should take a lot more effort to cool them down. Yeah. Some sort of viewport error now. think this is working. Hmm. I think the details are working. Yeah. Is there anything that looks off to you? I don't know. It looks believable. And I think the flames. There's some flickering that looks like it's happening, but it might be just the temperature dying off. But maybe when it's, moving on a liquid. Cool. Yeah, I'm gonna save this version. That's a good question. I might do like just a CG scene. I don't know. That's a good question. Yeah, I'll have to look because maybe I could find some like stock footage to use. Yeah, it's still testing. I think like the details are holding up better now. But let me open that flamethrower scene and let's take a pass at plugging this stuff in. Because who knows what that's gonna look like. I'll show you the whole setup that I have for that for 2. Yeah. For the final results of the flamethrower, I guess I might do some like full CG shot, or like, maybe try to find a shot from like a movie. There you go. Okay, I'll bring this scene over here. I think the final sim, yeah, this is the fire sim here, so I'm gonna delete everything in here and plug in all the work done in the other shot. Yeah, I do want to like get like a nice shot with like a better camera, and like maybe something similar to the reference video too. just to kind of sell it more, because like yeah, the goal would be to like to make a full-on like detailed tutorial like on how to do something like this, um and then kind of market that like on my LinkedIn with my network, showing that doing a tutorial in Houdini, and then if anyone wants to see it done live or have questions, then they could tune into the stream, because ideally I would like to have like the tutorial to be really nice and polished, that kind of competes with what else is out there, and then keep everything a little more laid back on stream. But let's turn that off. Save. Oh, I did some other things too in this file. So if I paste this here, no. There we go. No. Plug this in. No, I haven't actually made a lot of tutorials, so like I'm kind of like looking for a new gig, or I'm in the process of it, because I was working for DreamWorks and they're doing like a lot of letting go, not just me, but like they're downsizing the whole company. So sorry, my cat's on my desk trying to like knock stuff over. So I'm just kind of applying for other stuff, but I thought maybe it'd be nice to try to find other ways of still being a creative artist and not tied to any company. So I think it's gonna look a little off, but that might just be dialing in some different settings. Thank you. Oh, that's all right. So it's a little off. The details, like I'm reading fire. Like I mean, this is a little weird. Maybe I need to go back a bit, because I think there's some stuff I deleted that maybe I need. Yeah. Maybe before we... Yeah, that needs to get kept. And this is all stuff that needs to get removed. Forgot the wind was a little different. Okay. Oh, thank you. I don't feel well. I don't feel organized at all. I feel like I should clean up a lot of my stuff. Thank you though. Where's my scene? Here it is. Okay. So this should get plugged in here too. And then what's the difference? .3. Oh, so the buoyancy is way higher, which that should be fine. Okay. Yeah, I tend to. I wouldn't say I'm like the most technical artist that I've met. Like, out of all the artists I've met, I don't think I'm nowhere near as technical as like some of them. But I try to like be in between. Like, I'm not good at like hand drawing stuff either. Okay, so the buoyancy is way too high. I like some of it, but let's do like 10%. Because I have some wind forces here that are supposed to give us the wind of a low res simulation. So the whole way, let me actually show you this. So it's a very like simple pop sim for now that I am running here. And then this pop sim I'm making into like a really low res like emitter for flip. But before it gets put into the flip sim, I'm just adding some like random noise for fuel. So I've colored like napalm for red, gas for green, and then if there's any diesel, blue. And that just basically is going to control like life attributes and randomness in the sim. So we'll get a sim that kind of looks, let me see. This is kind of like what my sim looks like now. But if we look at it here, we can see the different fuels. So like the napalm, you know, is like a very viscous fluid, so it needs to like stick and stuff. So that's kind of that sim that we're going to be using as a fuel source. And then I have a low res pyro sim here that is ultimately supposed to give us like the overall velocity information, because like if you want to do like really large scale stuff in Houdini, sometimes it's better to simulate like a lower resolution and then use the lower resolution velocity on the high res simulation. So then you can get like your high res detail, but that lower resolution velocity is going to carry through. Because there's like that saying that like some people uh, say is, you know, when they run a simulation at a high resolution, the whole sim breaks and looks different. So uh, that's kind of like the workaround, like to break that. Uh, so yeah, let's run this now. I should probably save a new version just in case. Uh, so, so this is the old settings from my old sim, at least on the DOP surface level, with all the settings we've tested in the wedge file. So I imagine there's going to be things that still need to be changed. Oh, that's an older one, but ultimately we should get a better looking flame from here. And I did turn that buoyancy down, so maybe that buoyancy is going to have to get higher. Yeah. Vecting with the low res, but with the higher resolution. Yeah. That people do that all the time. Like, um, there's like even like the new like guided destruction stuff in Houdini. Like you could do like a really low res destruction of a building, and like that low res motion will give you like big pieces that feel heavy, and then you do a high res fracture, and then you plug in that low res as a guide, and then it just makes everything look, and it just makes everything feel like heavier and bigger. And same thing with flip. Yeah. um like I did some stuff like on Ruby Gilman Teenage Kraken, where like I ran a really low res simulation of the ocean with like the sea creature colliding with the water, and then uh, isolated areas where I wanted more splashes to happen, and just cranked up that resolution and used like the low res one as a collider. So then you get like high res flip colliding with low res flip, and then you can mesh them together. Oh, look at that. That's the way it's breaking up is looking cool. I don't like these shapes, but I think the way it's resolving so far looks interesting. The emitter needs work though. Like this little like string that needs a lot of work, but I think we're getting a little closer. It feels a little slow though. So maybe there needs to be a little bit more buoyancy. So the flames, because they feel like they're tearing up and shredding, but they're not going anywhere. Like I feel like they need to raise maybe a little higher. But I just want to cache it and kind of see. This looks nice though, like what's happening here. Like we're getting those flames that are just kind of like tearing off and going away very fast, and that looks, I think, a lot closer to what like we're seeing in the reference here. Like in these areas, like you could feel those flames kind of get born and tear off. I don't know. It looks completely different in some of these other shots though. Like I definitely have to fix the sourcing a little bit, but I think it's getting a little closer. Like this one's completely different too. Like the way like there's like a shot out and then all that temperature kind of goes up together. So the one I ultimately want to copy is this one, this middle one here. Like you get these little like tendrils of like fuel being burned, and then you get some like nice smoke rising. So it would be really cool to get like this result. And they did some like slow-mo of it, which I thought was really cool. So I think there might be too much fire too. But yeah, that's reading a lot better than what I previously had. All right, yeah. Well, thank you for hanging out. I'm still trying to find like a better schedule. I think I was like streaming a lot later at night and like messing my schedule up. So I'll try to figure some schedule out. But yeah, thank you for hanging out.